problem number 29 from section 5.4. We're going to use fundamental theorem of calculus part 2 on this one. Why do I know that I'm using part 2?
Because you have a definite integral.
A definite integral, and on my limits of integration, they are both constants. And they're not asking me what the derivative is of this. They just want to evaluate this. So I say to evaluate this, we start by saying, what is the antiderivative of the integrand? That's
One-third x cubed.
Okay, 1/3 x cubed is the first part.
Plus 2/3 x
Plus 2/3 x to the 3/2. Is that right?
Yeah.
Yes, sir, it is.
Everyone feel confident doing problems of that type? Okay? Well, I mean, this one, here's what goes on in my mind when I do the antiderivative. When I see something that looks like a polynomial, add 1 to the exponent. Here's my x.
That should be a.
There should be a cubed. Okay, add 1 to the exponent, and then multiply by its reciprocal. Okay, so this one, I have x to the 1/2. Add 1 to the exponent, and multiply by its reciprocal. Can we do that?
Yeah.
All right.
I made a funny face.
Yeah, you did. Now, again, my notation is after we find the antiderivative, we remind ourselves that we are going to then evaluate that expression on those bounds. So we'll say 1/3 times 1 cubed plus 2/3 times 1 to the 3/2. And there's my evaluation of it on the upper bound. And I know you're saying, I know the other stuff is 0,
Yes, all of it.
but I write it out anyway. All right? And when I'm all done, I end up with 1/3 plus 2/3, which is 1. Nope. Check mark.
Who's dying?
You know, like 5 years from now, that expression is going to have no meaning to anyone.
What, check mark?
No, they wouldn't.